Okay, here is the video guide for lesson 3.1.3, focusing more on our dilation and similar figures. So in combined lesson 3.1.1 and 3.1.2, we learned a little bit about dilation, which is growing or shrinking a shape by a common zoom factor, meaning all the side lengths are growing by the same zoom factor or being multiplied by the same thing. Today, we're going to practice more setting up ratios to figure out what the missing sides would be, and then we're also going to investigate what's happening to the perimeter of these shapes as the shapes are growing by this zoom factor or being enlarged. Okay? When we look at this first problem, we want to talk about a sequence of transformations that carries the one triangle on the left onto the triangle on the right. Okay? And so think about our transformations: rotations, reflections, translations, and dilations, and we'll use some mix of those to come up with how we wanted to get this one on the left to land exactly on the one on the right and write out what you did. Okay? The next thing we want to do is use ratios that show that these two shapes are in fact similar. Okay? So some kind of ratios here to show that these are similar. Here we go on to see, again, practicing our ratios. What other ratios could we have used? So maybe in the problem before you did 7/2 equals 21/6, and that would have worked. Now what other ones can you set up here and see to show that, yep, these would be similar again? And we saw a little bit about this in 3.1.1 and 3.1.2. So what other ones would work? In D here, she compared the heights. She wrote 2/7, so 2/7, and then she's writing 21/6, and it's not working. So we need to look at the ratios she's creating here and explain why the ones that she's choosing and trying to set equal to each other are not working. Okay? Look at numerator and denominator of both of those and which number she's choosing for those. The next one here, we're going to start practicing setting up these ratios to solve for x. Okay? And there's different ways to set these up. For one like this, you could choose to do, and this is maybe one that I would choose to do, but there's plenty of other ways to do it. If you wanted to set up a ratio, you could do 4/2 equals, so I took this 4 and this 2 because those sides correspond, and then I'm going to do x divided by 6 because those two sides correspond. The 4 and the 2 are the 4 and the x are the numerators in both because they come from the big shape. The 2 and the 6 are the denominators because they come from the small shape. And again, I'm choosing 4 and 2 because they correspond, and x and 6 because they correspond. And then cross multiplication here would take me to the next step, and this is where I'll stop on this one. 2x equals 24. 2 times x gives you 2x, the equal sign stays in the middle, and 4 times 6 gives you 24. You're one step away for solving for x. Next problem is pretty similar to that, gets a little more challenging. Okay, we have 3 and 4, 6 and x. We need to think, okay, how can I set up the ratios to solve this for x? And then which sides are corresponding? And with the shapes being rotated, kind of visualize, okay, if I perform some kind of transformation, I can get the one on the left to look exactly like the one on the right. And then I can look at more closely which sides correspond to set up my ratios. And again, set up the ratios and solve for x. A lot of different ways to do it. Here, a challenging one, because we look at the shape on the left, we have a 3 and an x, and we have a 21 and nothing. Okay, but we know the perimeter of the entire shape is 60, and that this shape is a rectangle. And so we have 21 here, which means this side down here is 21, which means 42 of your total perimeter of 60 is taken up, because 21 here, that's 42. So you only have, if you have 42, you only have 18 left, and that 18 needs to be split into this side and this side. And so you can figure out what needs to go on this left side, and once you have what goes on this left side, you can then set up your ratios. 3 in that missing number, x and 21, you can set up your ratios and solve for x. If you get stuck on this one, let me know. I can help you further with it. Here's a really fun one, I think. We have this original U here, and we're going to try to enlarge it by a zoom factor of 1.5. And we need to, again, if it's a dilation, we need to increase all of its parts, all of its sides, by that zoom factor of 1.5. So we look here at the base. The base is 1, 2, 3, 4, 5, 6 units long. I got to increase that by 1.5, and that becomes 8 units long. And so if I wanted to do 8 units long, I could do 1, 2, 3, 4, 5, 6, 7, 8, and my new base would be there. And then I can increase each part of my shape here and get my new zoomed in shape. And then I want you to write what would the new height be after you increased it. And when I'm talking about height, I'm talking about outside height, not inner height, outside height, okay? The next part is we are going to find the ratio of the perimeters. So once you have your new shape created, you want to find the perimeter of that new shape, which is adding up the total distance on the outside. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and counting all those blocks on the outside to find the old original perimeter. Then you got to count the outside blocks on your new shape to find your new perimeter. And then what I want you to do is new perimeter divided by old perimeter and see what you get when that happens. What would be kind of your zoom factor when you do new divided by original? Lastly, we want to say that Casey enlarged her U so proportionally so that the new height was 10. And we want to figure out, okay, her new height was 10. Our original height was what? And then what can I find that zoom factor to be between the old shape and the new shape? Okay? And remember, you can divide new height divided by old height, and you could define the zoom factor there. Here we have a good one where we drew a 60-degree angle as shown in diagram at the right, and then extends the sides like you see. So it started diagram 1 and we extended the sides here in diagram 2. Therefore, the new angle measurement must be 120 because we doubled the side lengths. Explain if you agree, or if you disagree, explain why you disagree with his answer. Okay? And think about that's a 60-degree angle. Think about what a 120-degree angle looks like, and does it make sense in these two diagrams? Lastly, we have looking and investigating area. So we want to find the area of this shape on the left. Not too bad, right? Base times height. Then, kind of my fault here, I didn't add a drawing feature onto this one, but we want to increase or enlarge this rectangle by a zoom factor of 2. So the 7 becomes 14, the 3 becomes 6, and then we want to find the new area and the new perimeter. Okay, and we're going to write that in this box. And then we're going to relate the area and the perimeter in the bottom box. And so we're going to take, again, new perimeter divided by old perimeter, and we're going to take new area divided by old area, and we're going to see what happened. Did the areas double? Did the perimeters double? Did the areas quadruple? Did the perimeters quadruple? We want to see what happens. Okay? Again, if you get stuck on any question throughout this lesson, just email me, and I will be happy to set up an individual video to explain a problem or multiple problems on here.